And I've been working with the Oracle security products basically for the last 15 years. And now I'm part of what we call the EMEA team that is doing security advisory across the board. So during a day, I can have a meeting, of course, virtual with both Saudi Arabia and Israeli customers. That's fun. And all across. So it's all about, to me, it's all about cloud and cloud security. That is the main thing I'm working with today. But also spend quite a lot of time with customers, of course, in Norway and the different challenges we have. So the basic thing I'm going to talk about today is business continuity. But the main risk we see today against business continuity, and that is the A in the CIA, the security triangle. The most important thing that has made major disruptions in all kind of IT production that we've seen recently is due to different kind of cyber attacks, from ransomware and other type of attacks. So business continuity with an angle that there are some bad actors out there that really would like to damage your infrastructure is part of the business continuity discussion. This is a picture taken through the periscope on a Norwegian submarine guarding the Northern Sea. And the oil rig there is owned by a company called Equinor, which is perhaps more known for you as Statoil. That used to be Circle K, or Circle K acquired the retail part of Statoil. So it's a Statoil-owned oil rig. And they're guarded by the Norwegian Coast Guard, but also with Navy vessels from Germany, UK, Denmark, and other other NATO countries as well. The main reason for it, you see in the map to the left, that's the pipe structure going from the Northern Sea to Europe with oil and gas. And we saw what's happened to the Nord Stream 2 pipe. And of course, we're pretty afraid of the same thing happen in Northern Sea. But what Equinor is also seeing quite heavily today is a number of cyber attacks against the Equinor infrastructure, because Equinor is the main company that is running all the gas pipes. And a number of those critical systems are, for historical reasons or whatever, are hosted on Oracle databases. The other picture there is the NASAMS, which is the surface-to-air anti-missile system provided by a company called Kongsberg Defence and Aerospace, which is another Norwegian customer I've been working to. And we exported some of them, actually we donated some of them to Ukraine. And the third picture is something that came in the Oslo fjord to the city of Oslo yesterday. It's the new aircraft carrier from the US called the USS Gerald Ford, which is the world's biggest ship. And actually, and it's the first international trip of that aircraft carrier going straight to Scandinavia. And that's kind of showed the importance from a NATO point of view, where you are located and we are located. So that's interesting. So that's a little introduction. So both Kongsberg Defence and Aerospace and Equinor are customers of us. So we've been working with them for some years and discussing different kind of security topics. And going to show us a customer case at the end that is partially taken from some discussion we had with these customers. So what I'm going to discuss today is a little bit of business continuity. What is the main reason for disruptions? How we can mitigate the risk from a little bit from a cloud perspective, also about the way you operate IT in general, and also looking a little bit into a customer case study. One of the things that we're normally circling around is the NIST framework for how to protect you, how to make sure that you're resilient, how to make sure that you are available. And that's all goes in circles. It's not a one-time job. It's a continuous process where you start with identifying which systems do we have. What is the criticality of the systems? What's this effect on the society or effect on the company if a system is taken down? That's entirely the customer that knows what kind of data they are processing and why they're processing it. So that's kind of something, but it's an evaluation that the customer or the business side or the business owner or application owner has to do at the customer. And I see many customers has not done that. So they don't do and based on what they identify, they need to do a prioritization. Which systems are most critical? So which one do we need to get back into production first if something goes wrong? Then, of course, the next step is what you can do to protect yourself. And the challenge with protection is that you could win in 99 out of 100 attempts. The hackers only need to win once. So you can't. So what's the approach we normally take is that it's not a question is if you are going to be hit. It's more a question about when. So when you are hit, then of course, how do you detect that something goes wrong in my estate of IT solutions? Is there somebody moving around there? That shouldn't be there. Some piece of code in there? That shouldn't be there. That's the detection phase, and that's more the technical piece. And of course, they know how to respond. That's again more an organizational thing. Do you have an incident response team? Are they trained? Do the staff know how to act in case something goes wrong? We have a number of incidents, at least in Norway, where it's obviously we have never trained. People don't know what to do when something goes wrong. And the response units, they are not in shape at all to be able to deal with a major cyber incident. And then, of course, when something goes wrong, it's also about how do you recover from the incident. And it's not recovery in the sense of doing a backup restore, it's a recovery of the service. One thing is to restore some virtual machines, but as long as you don't have your data, it's really of no value. So you need to see how do I recover or restore my business function or my application, including the whole infrastructure around the application that you need in order to be able to operate. So these are the NIST framework that you're circling around. There was one major incident some years ago with a NotPetya virus that was hitting Maersk in Denmark, severely hitting Maersk in Denmark, for taking out the complete VMware infrastructure. And it took them a couple of years to get back into business with everything. And it cost them a couple of billion Danish kroner. And this statement is coming from one of the IT managers at that time, that protecting is important, but equally important is to ensure your recovery process is strong. Because in their cases, obviously, the recovery process was not strong enough to deal with an attack like that. It's a very interesting case. And some is speculating that the whole thing was a major cover-up to hide the fact that it was a massive attack on Ukraine, actually. But the world was focused on Maersk, but the speculation is that the attack was actually on Maersk was a cover-up for actually a cyber attack on Ukraine. But nobody knows, but that's some part of speculation. By the way, if you have any questions, feel free to interrupt. It's a little bit dark in here, so I'm afraid you're going to fall asleep. So ask questions. So what many customers is doing, or what many organizations is doing, they're doing scenario-based planning. So they're setting up different scenarios. If it happen, how are you going to handle it? Normally, an organization is thinking, okay, if we are hit, we do a backup restore, but they really don't have a plan for what are the different threats we have. It could be operational threats. It could also be any kind of natural disaster or whatever. So having the different scenarios, and of course you can't guess what's going to go wrong, but at least something is known. So doing a scenario-based planning on a complete business availability plan is what normally the approach that will work the best. It's a very interesting old example of that. I don't know if all of you actually remember that, but we did have the oil crisis in 1973. And that was a classical textbook example of one company that was doing a scenario-based planning before that incident. That was Shell, the Shell oil company. They were the only oil company that was prepared for something like that, that the Saudi Arabia was just cutting off the oil supply to the Western world. They planned for it, and they actually knew how to handle it. And they were the only oil company that just came out of it with a really high profit. So that's a classic textbook example of planning for the unbelievable thing that could happen. You perhaps know about the kill chain. And in order to understand how an attack evolves, the kill chain is important. So the kill chain is describing how you start with a tiny little virus that could be implanted some way or another into your environment. Deloitte has on YouTube a pretty cool video showing how they did that through social engineering. Was a artificial telco company in the UK that was having a stand outside of the office building with nice girls on rollerblades going around selling advertising for mobile subscription. And by the way, do you want this memory stick with some more pictures of me? And guess what the mails did? Taking it, put it into the laptop, and voila, the hackers were in. And then it takes some time to work around, recognize, figure out how the infrastructure is, and some time to spread the virus. And then after a while, they are able to execute and turn on the kill switch. And in most cases, when ransomware, that means that they're removing the encryption key. But ransomware is just a subgroup of what we call the advanced persistent threats. Could be other things going on. We had an incident in one of the larger hospital areas in Norway. That it turns out the Norwegian National Security Authority found out that somebody has been in these systems for a year, sneaking around, implementing small viruses here and there. They guessed it was China, but there was no clear proof. But it took a year before they actually discovered that they had built up a large volume of viruses that was ready to attack when somebody was pushing the kill switch. So that's how the attacks involved. So one of the things you do from protection point of view is, of course, to reduce the amount of what we call south-west movement. Normally in an infrastructure, in a classical organization, you have your internal network, but the internal network is very open for sideways movements. So one of the really things to reduce the effect of an attack like that is, of course, to have micro-segment your network as much as you can. So let's see how we can mitigate the risk. One of the things that I strongly believe is that moving from on-prem to cloud is one way of mitigating risk. The reason for that is, if you look at the green boxes, these are the areas where the cloud vendor is responsible. It's what we call the shared responsibility model. All cloud vendors has this. So you have to the left, you have everything you have in your own data center. Means that you are responsible for everything. That means that if you have a virus that might affect that infrastructure, it might affect across the whole infrastructure. If you move to the cloud and look, for example, on the IaaS, it's a very, very clear distinction between what the cloud vendor, like Oracle, is doing and what the customer is doing. And that's at the hypervisor level. We only provide you access to create VMs. You don't have access whatsoever to the hypervisor or the hypervisor below. So it means that if an attack is coming in from the upside, from the customer side, it won't go below the hypervisor. It will be stopped before it goes down. And all the hyperscalers like Oracle, Google, Microsoft, AWS, we do have an army of security professionals that's protecting the infrastructure. And you can really imagine what would happen if some of the big hyperscalers were really hit by a virus. We basically out of business in a short period of time. So you can say that the lower layer of infrastructure might be much more secure if you move to a hyperscaler compared to try to do the same thing on-prem with normally scarce resources. Of course, if you are a company like Telia, like Telenor or something like that, like the big telco companies, they do have the big security departments, but normal organizations don't have that. So that's one thing. All the hyperscalers, of course, like we do, has built a strong infrastructure. What we're doing a lot of stuff like, for example, at hypervisor level, we have a very thin hypervisor. All the real virtualization on network and storage, it's outsourced to run on specialized hardware. It doesn't run, it sits in the hypervisor. So if a computer is, for some reason, is hacked and you got a leakage through the hypervisor level, it won't affect the virtualization level because it's running on separate hardware, on a separate type of microchip, so it's not Intel-based. So do a lot of stuff like that to encrypt everything at network level, blah, blah, blah. So it's a big story about how we or how the cloud vendors is actually protecting the lower level part of the infrastructure. And for security professionals, of course, they are normally used to, we need evidence. One thing, we hear what you're saying, and here, by the way, here's the number of evidence that all the certifications we are doing, and everybody need those certifications. But what I'm seeing, especially in public sector, you need to find and document that I've actually assessed and seen that these certifications are in place. Typically, the ISO 27001, and all the whole ISO series, and a bunch of others. I don't know many RFPs I'm responding to public sector. We're saying, are you certified? And then I have a bunch of lists. And that basically having the proof points that we really do what we say, what we are doing. And in order to validate your IT infrastructure, doing stuff like that is really important. But The other discussion we had, especially after the pretty violent attack on Ukraine, is the geolocation discussion. On the weekend when Ukraine was attacked, we had a volunteer program in Oracle. Is anyone who wants to sign up to help Ukraine moving critical data out of Ukraine to the Oracle Cloud Center in Frankfurt? We did have spare capacity in Frankfurt, and we pretty quick offered Ukraine, we can move whatever data you have out of Ukraine to Frankfurt. So we spent the weekend and most of a week assisting what was a colleague in the IT business, hosting some of the large data centers in Ukraine. And fact of life, a number of organizations in the Nordics, both inside Ukraine and also in the Nordics, was actually hosting in Ukraine data centers. So it's critical not just for Ukraine, but also for businesses in the rest of the Nordics to make sure that we're able to protect the data. So it was pretty crazy to sit in my kitchen at home, a peaceful environment, talking to people in the different data centers, helping them, and we help them with doing export, import, Oracle databases and stuff like that. And they said, sorry, we need to have a break. We have the air attack alarm is going off. We need to find a shelter. We're back in 2 hours. I said, okay, well, I got my coffee and hope you we kind of hope you will survive. So it's kind of surrealistic. Really strange to speak with people that was working under distress and sitting in your own kitchen in peaceful environment. But we were able to help them. We were able to move quite a lot of data out of Ukraine during the first weeks. Even though the infrastructure was attacked, the fibers was attacked, and we saw some pictures how they were actually repairing the fibers, why the missiles was going over their heads. So it's really difficult working conditions for the people over there. But we were able to do it. But that also raised the question about the balance between having only national data centers and data centers outside the nation. We have a huge debate about that in Norway right now, because you see Norway, we are not, Norway is EEA, so we are partially part of EU. But as you see Norway and Sweden, we do have some fibers going out across the sea. So it's pretty easy to cut off the lines from Norway and Sweden. Partially Finland the same. So one thing is, if somebody's cutting off the lines, yes, we need to have a local data center. But on the other hand, if you only have the local data centers and some malicious attacks is able to take out that data centers, we are also basically screwed. So the debate is to having a hybrid model for having national security data and part of the critical infrastructure, both in Norway and in a cloud infrastructure outside Norway. So have the duality to deal with. So that's one of the debates that is going on. Interesting to see how that is ending. One of the things we've done in Oracle, we create something called EU Sovereign Cloud. It's from a business continuity perspective, very interesting, and we're using that in some customer cases. And then the idea is that we have a completely separate legal entity with a completely separate set of staff. So people who are employed in the EU Sovereign Cloud organization do not have an employment within Oracle. And none in Oracle, even though it's an Oracle-owned company, no one in Oracle has any access at all to the data centers that is operated by the EU Sovereign Cloud. From a business threat point of view, that's interesting, because it means that if somebody is threatening Oracle employees to shut down services, they have to threaten Oracle employees in 2 completely different companies in order to be able to do that. So we have a customer that is both deploying in the public cloud and is planning to deploy in the EU cloud to make sure it's a complete separation on the Oracle side, and they're setting up the same separation on their side. So they have some admins that have access to the cloud tenant running in the public cloud, and they have a different set of admins that only has credentials for the tenant that is running in the EU cloud. So separation both on the customer side, so it's not just 2 eyes, but there's 4 eyes on the customer side that needs to cooperate to be able to damage the infrastructure, and they're the same way of thinking on the cloud vendor side as well. So that's why it's interesting. And we also have some other models as well, where we could, for example, set up a data center locally in the country. We have something called Oracle National Security Regions with staff that is graded, able to work with classified information, that you have the security clearance. So other versions as well. But from a pure, also I said, business continuity point of view, having the separation of four eyes, both on the customer side and the cloud vendor side, could be an important way of thinking. Yes, and of course, security in the cloud, that's all the tools any cloud vendors like us is offering you that you can do to make sure you do part of the coin correctly. We, as a cloud vendor, and the other cloud vendors, of course, need to do their part correctly. But you also need to provide a number of tools you have. So there's a whole bunch of tools there. I'm not going to spend time on that. What I'm thinking is the really important thing, and whereas cloud as a methodology has value from a business continuity point of view, is what we call platform re-engineering. The beauty of cloud way of thinking and the cloud culture is that you software define everything. You software define storage, software define compute, software define network. And that means that you can re-architect your services to be purely software defined. So it means that if somebody is attacking your network, it's not somebody that needs to do a reconfiguration of a switch by logging onto the switch to do it. It's not somebody that needs to manage your storage independent of the way you manage everything else. You move away from doing manual operations on your devices and doing everything as code. Doing everything as code also means that you will have a normal software development lifecycle, not just for the code you deployed, but also for any changes you do in the IT infrastructure. It's done in the same way, and if it was a code change. And that is some of the things we really seen with the cloud way of working, is that you move to software-defined everything and not do manual configuration of Windows. You don't do manual configuration of the operating systems or the switches and so on. Which opens up a whole box of new ways of redesign and rethink thing. So what we encourage people to do is also take the cloud native way or DevOps way or platform re-engineering way of working as the standard methodology. What we've seen, and that's interesting from a backup recovery point of view, what we typically see, a number of customers, they do, for example, have a large VMware estate. In Norway, VMware is, I guess, 99% of public sector is running everything on VMware. What they do, if they should deploy a new Java-based application, they create a Linux VM and start and apply Tomcat or WebLogic server or whatever on top of that Linux server, and then deploy the Java program on top of it. So then we're having one Linux VM per service. And the same on Windows. When they develop something with .NET and would like to develop and Microsoft deploy it on Microsoft Information Server or whatever, they create a new Windows server per service. So then with a large number of virtual machines. And the question is, why do you need to have a complete operating system with Linux and everything just to run a Java service, for example? Why not put it into a container and run it on a Kubernetes stack instead? So you need to redeploy it. You don't need to recreate a VM or using vMotion or whatever to recreate the VM. You simply pull it from your Docker repository. And if you do any changes to it, you upload it to the Docker repository and repull it. If something goes wrong, just throw it away and pull it from Docker repository. Much faster way of re-establish your service. And again, you built everything as code in your CI/CD pipeline. So it's much more efficient to re-establish your environment in that way. That's one example of how you could simplify your infrastructure. You still have the same Java service, providing exactly the same service to your business, but the underlying infrastructure is changed in a way so it's much easier to restore, much easier to manage, and from a security point of view, less attack surfaces. Another thing in the cloud native or cloud way of working is, for example, when it comes to software-defined networking. It's pretty hard when you have 5 different switch vendors in your environment to set up a microsegmented network. With software-defined networking, you could basically create one tiny little subnet with just a few firewall openings you need just for that service and basically built a little realm around your service. And you have complete control of the traffic going in and out to that service. In contrast to a normal VLAN-based environment where you have a service VLAN where everything has access, and then you have your application VLAN where everything has access. Meaning that the south-west movement is possible in a microsegmented way. The south-west movement is much, much more difficult. So there's a few examples there that I'm going to go through and what you can do. The most important thing, I think, is to move into a platform engineering type of culture. Script everything. Don't do manual changes to an operating system. Don't do manual changes to any kind of Tomcat or whatever WebLogic server or whatever kind of material you have. Yeah, I don't know if you know the cattle versus pet way of thinking. Cattle, if they get sick, you shoot them and buy a new cow. If your pet gets sick, you go to the vet and pay enormous amount of money to try to heal it. And the same way of thinking applies when it comes to platform engineering. If a machine goes down, just kill it and redeploy it. Don't try to fix it. And everything is done in code. So your complete infrastructure is stored in the source code repository. Hopefully not public GitHub. So everybody knows what they're doing. So everything is stored in the, and any infrastructure changes is managed in the same way as you manage any kind of other code changes. We have one customer, what they are doing is that they redeploy the complete environment every night. Just kill it and redeploy it, just to see that everything works. And if it doesn't work, they have the version from yesterday that they can redeploy. But it also means that they're really good at it, that way of doing. And they are doing that in their internal data center. It's not even doing it on the cloud, but it's the platform engineering mindset they have created as really important way to make sure that you have a more resilient infrastructure. You are able to build it because you script it, and you're able to manage it, and you're able to restore it when something really goes wrong. Here's just a picture of how you can microsegment your network. And since you're scripting everything, it's so much easier actually to create a completely microsegmented network. You can have 2,000 firewall definitions. It's all in script and all in code, so it's easy to redeploy. So it means that every little service only has allowed the traffic in and out that service required and nothing else. So if somebody is attacking that Docker container, because you're not using operating systems anymore, you're using Docker containers, if somebody is able to sneak some code in that Docker container, it won't be able to spread sideways. One thing we're also working aggressively for, sounds bad, but still, one thing we're working for our customers is also working on something called a landing zone way of thinking. And we are using a framework coming from Central Information Security in the US called CIS, where they created a landing zone or a blueprint of how to set up a landing zone. The whole idea is that those who are managing the network are in their own little realm, or in Oracle terminology, we call it a compartment. And you have a least privilege model. So the network people is only able to change the network, versus the one who is creating compute nodes or Docker containers or Kubernetes stacks. They're only allowed to do that. So if they need to have some network access, they need to go to network people to make sure it happens. That is also a way to make sure that you have better control, so for example, avoid data loss. Somebody is having open to the free internet as in pushing data out without telling you. That's much, much more difficult in a way like this. So having a very segregated on least privilege model based on your job role is a way of building the landing zone. So the landing zone way of thinking is also coming into the platform engineering way of thinking. Because again, you mostly script everything, and you script it in a way and setting up policies in a way so you know that the guys who are assigned to the network team, they are only able to change things in the green box, the network box. The guys who are working with security are the one who owns the policies, and they're the only one that is allowed to change the policies. And how did they change the policies? In the script. They are allowed to run. Don't do it in the UI. So this is a cloud way of thinking that can also be applied quite often on-prem. It's more difficult to do on-prem because you don't have the software-defined networking thing. So moving to some kind of SDN is absolutely a way forward, and moving to scripting is a way moving forward. I mentioned moving to containers. Get rid of the large amount of attack surfaces. Majority of ransomware attacks has been out there is because of old stuff on a Windows server. NetBIOS stuff, all kind of mail protocols, whatever, that is still in there for compatibility reasons. By moving to a Docker container, we reduce the number of servers you need. It's more easier to lock them down, and you move away from Windows over to Linux. Yes, there are viruses on Linux as well, but the amount is still fewer, and you can also easier to create a minimum Linux, an absolutely minimum what you need in order to provide the services. You don't need to install any UI, you don't need to install any mail servers or whatever. So you got a more manageable environment with less attack surfaces. And it's much easier to pull a Docker image and throw it into, for example, your Kubernetes stack instead of recreate a VM. So that is the cloud native way of working. That will also can do it on-prem. It's no problem running Kubernetes on-prem, but it's a better way of working in order to make sure that you're easier to recover and less attack surfaces and less sideways movements. Another thing, we have a number of customers that is developing stuff in Java. A lot of that Java code is actually fairly old. Java has evolved quite a lot. We introduced quite a lot of new stuff in Java 9 and Java 10, especially around modules and how you could shrink the size of the JDK to only contain the code you need to run your little Java program. And we also introduced something called Helidon.io, which is a framework that makes that you could take your web service or your REST service and put it on a Java SE node. You don't need to run a full stack Java EE container in order to do it. So that's also one way that you can say, and I did that with one customer. We had a ABAC solution from Oracle that we rewrote, and we get rid of 5 WebLogic servers running on VMware and condense it down to 2 Java SE servers. That was just spin up Java SE and that's it. That then could be easily put into a Docker container. And we also introduced Graal VM, which is a way that you're basically generating binary code out of a Java program. So you can also execute this as binary code and not through the JDK. That again, we take down, I did an example. We were having a WebLogic server hosting on a VM that was taking something like, not hosting a Docker container to put a Java service on. It was about 1.2 gigabyte Docker container. And we go through the chain down to Graal VM, and we run it in a Docker container that was less than 100 megabytes. It's much easier to maintain, but it's still the same Java code. And you can think like that with a number of other programs and programming environments you have as well. In the old days, we used to have the J2E containers, J2E servers, doing, for example, clustering to make sure that had active clusters. But with Docker and Kubernetes, that is taken care of. You don't need that any longer. So it's a way of thinking and rethink how you deploy your application in a more modern and easy to manage environment. And the same way of thinking also goes a little bit into having a backup restore discussion. If you go to any kind of event talking about ransomware, 95% of them is going to tell you need to have a 3-2-1 backup strategy. And you focus on the backup. How fast are you doing the backup? How fast are you going to do the restore? The question I'm asking is, what are you backing up and what are you restoring? What can you, instead of, if you have 500 VMs and 400 of them are stateless, why do you need to back them up and restore them? Why not throw them into Docker containers? Or if you still need to have your VM, why not script it and recreate it instead? And if you have the cattle and not the pet, you know that the one I recreate is equal to the one I just killed. And normally recreating a VM is much, much faster than restoring it. So it's a way of thinking that you can see, okay, how can I build my infrastructure, as code? I know how to redeploy it. I know how to restore it. So I can rebuild and restore faster than the traditional way of back up everything and try to restore everything. That took Maersk 2 years to do, even on VMware. So really evaluate what you're backing up and what you could restore. And the other thing that is also part of this is that modern development is fine. You have independent teams, and you have stand-up meetings and all that kind of stuff. And we've seen, for example, organizations in Norway that has autonomous teams creating all kind of services, because especially in the public sector, they want to become digital much faster than they can do in the traditional waterfall development model. What some of these organizations are forgetting is to create the standards. So each team is able to create the application with the programming language, with the runtime environment, with the data storage and databases they prefer. So if you have 5 different themes, you end up with 5 different sets of technology stacks, which is cool because they're able to come up and running pretty quick. But 2 years, when the teams has left the building and you're going to maintain it, you have a huge problem. And we also seen from, for example, from the open SSH virus that was out there, or flaw that was out there, was many customers that did not know which version of OpenSSL, which version of OpenSSL did they actually use. They did not have the necessary source code control to know in which pieces of my infrastructure did I have the affected version of OpenSSL and which version did I not have the affected version of OpenSSL. So the kind of chaos you're getting if you don't, yes, you have an autonomous teams, but make sure that you do have sufficient control of the framework they're allowed to work within. And I mean, if you, like I said, if you have a Java program, if you deploy it on WebLogic or Tomcat or Java SE, it really doesn't matter for the efficiency of the programmer. But quite often, these kind of discussions could really take time because people are passionate about it. And you need to get to the cattle way of thinking. Forget your pet. My pet used to be WebLogic, but it's not my pet any longer. so you need really to set the standards. To also, if you pull and download any kind of open source code, you really need to know what's in that code. So you have control of, is this code safe? Will this code be maintained? We've seen a number of open source projects that has been very successful, like a number of things that is coming from Apache. But you also seen that there's been smaller projects out there that dies after a year. And people are downloading the code and no clue what's inside that code. Nginx is extremely popular. It's a Russian-made product. Still want to deploy it in a critical infrastructure without knowing what kind of code is in there. So people are careful. So yes, make sure that you're having an infrastructure that are able to restore. But restore does not mean that restore from backup. It means that it could be restore or rebuild, or different strategies around that. And also make sure that you don't have a complete chaos on what the amount of open source technologies or closed source, whatever, technologies you have. One of the big challenges we've seen among customers, especially when they have these autonomous teams in a REST kind of world, in a microservices-driven way, is that if you should do a point-in-time recovery for a service that is built out of 15 microservices, that has 15 different data stores, how do you on earth are going to be able to do correct point-in-time recovery on those 15 data stores? It's a major task. So again, think a little bit about consolidation. Do I really need to have programmer 1 because he loves MySQL, he's using that, but programmer B would like to use MongoDB, and programmer C is using some others, Postgres or whatever? Yeah, do I then have an infrastructure that is able to be restored to a known point in time? Because we're doing point-in-time recovery. Most people thinking, yes, we are doing backup, and we need to restore our most recent backup. The problem is, you don't know actually what's hit you. It might be a ransomware virus, but it could also be some virus that was actually changing your data. So it means that you need to go back to a last known good state. When it was last time I know that my data was okay, was not filled with. It might mean that you need to do a point-in-time recovery a week ago. That is also something you need to take into account in your backup restore strategy as well. So I'm going to discuss a little bit about a case study, a customer for something we did for a customer. Just to set the context, I was one of these customers operating out here. They are extremely afraid of a massive cyber attack. So they have a huge semi-trailers stored somewhere else that is filled up with laptops that is blank. So in case they got a virus that infects the complete infrastructure, they have a number of laptops ready that they could throw in. And the question they ask is, okay, how can we make sure that we maintain the integrity? Nobody has changed our data. And how can we make sure that we maintain our availability? And one of the applications we're discussing here is an application called Dispatch, which is responsible for dispatching natural gas from the Northern Sea to Europe and Germany in special. So if somebody is taking out that application, well, when it's summer, but in winter, the Germans would freeze. So that is the case. Just to put it into context and understand what you're talking about, take this first. What we did is we said, okay, you need to categorize your applications. How critical are your applications from both a operator of essential services point of view, as a critical service to the society, and what applications are critical for you from a pure business point of view, since you are a publicly listed company. So that's the first exercise. The other thing you need to do is to take into account, okay, what do you think is the current threat level? Before February last year, the threat level in our part of the world was fairly low. That changed dramatically. But on the cybersecurity side, we've seen that the threat level has been pretty high for quite a long period of time. So you need to define, okay, what is my threat level? So if I think both I have extremely critical application, and we also see that our company is right now under a fierce attack, that gives what we call a higher continuity level. If it's a less business critical application, and we are in a pretty normal, peaceful time of the period, then you are at business continuity level 1. So we must matching both the criticality and the threat level. And to make it simple, so we have 3 continuity levels. And then the customer has to plot, or what they by itself would do, is to plot their applications into any of these 3 boxes. And then have a standardized infrastructure in order to deal with it. What we was discussing in this case was something called Exadata. It's a Exadata cloud service. It's a service Oracle provide. Basically, it's a purpose-built database server. And since these applications we're discussing here were critical, was built on Oracle database, they had a purpose-built hardware, or would like to purchase purpose-built hardware for running Oracle databases. And basically what we see here is how is the split in responsibility. Since it's a cloud service, we take care of everything from the hypervisor and down. The customer is taking everything on from the VMs that is spin up on the purpose-built machine, and any kind of database management is done by the customer. So it's kind of an IaaS type of service, but we split it, the responsibility model very clear. So this means that if a internal bad actor at the customer, he will not be able to reach the red spots. But on the other hand, an internal bad actor at Oracle will only be able to reach the red spot. He will not have insight into the customer data. So it's a clear separation. But a bad actor could shut down the system at both ends. So what we said is that you have... Oh, it's a slide missing here. Okay, I can explain it. Sorry about that. So from business continuity level number 1, you just have the lower box. You do not do the replication to the hot standby. Just have the lower box. You're spinning up the database server, having applications on it. It's by itself, highly available. You have a way of doing backup, blah, 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 the normal standard stuff that you're used to. So that is the box on the level. That is if you are in business continuity level 1. If you then say, okay, this is a more critical application, also in normal peaceful times, we move to business continuity level number 2. We create a hot standby. And of course, the beauty of the cloud is much easier to spin up different kind of hot standbys than instead of in your own data center, you have to buy your own hardware and rebuild everything. And you can even having a hybrid model saying, okay, in a normal state, we are running the application in-house, but in order to have a hot standby without getting a rip-off from the hardware vendor, we create a hot standby in a cloud data center. So it means that if my data center is taken out for some reason, then I still have a copy somewhere else. So that's business continuity number 2. When it's really starts getting interest is when we move to number 3. In this case, we are doing everything in the cloud. What we have, we do have what we call a tenancy. I think that is pretty common across all cloud vendors that you have a tenancy. So you have a tenancy with a set of tenancy administrators. Those are the tenancy administrators are those who are allowed to change any resources in the services that is available for the tenancy for the cloud customer. They said, okay, we have 2 separate cloud tenancies. So you have 2 independent set of infrastructure administrators in our cloud. So it means that if somebody is putting some pressure on an Acme employee, he will only have access to part of the infrastructure, not the full infrastructure. And also what we did in this case, we engineered an air gap solution. So the guys to the right, they had to pull a backup, restore it, and re-enable it. So in case somebody was fiddling with the data, we still have a fresh copy on the other side. And of course, we put some time lag into it and so on. So in that case, this means that if somebody was really able to damage the full infrastructure on the left, you still have a data center in a different physical location. To the left, it was in Amsterdam. To the right was in Frankfurt. So 2 different physical locations. And in case city of Frankfurt is going down or somebody is really damaging both the Oracle infrastructure or the customer infrastructure, you still have a completely separate environment running a completely separate geological location with a completely set of admin staff on the customer side. What we then, in addition, did was on the right side, we was using what I mentioned earlier, what we call the EU Sovereign Cloud. The purpose of running the EU Sovereign Cloud in this case was not to be GDPR compliant. The purpose in this case was to make sure that also on the Oracle side, it was completely different staff that was operating the cloud. So this means that you need to put pressure on both 2 different set of Acme employees and 2 different set of Oracle employees in order to damage everything. So that is the threat level 3, the maximum availability architecture. And this is the architecture we are building now in order to make sure that Europe are getting the amount of natural gas that we are able to supply. So that is kind of a way of thinking. And you go, and part of this, Acme in this case, a company making everything is Acme. Of course, everything is scripted, so it's easy to redeploy. It's banned to do manual changes on operating systems, so using Terraforms and Ansible to make sure that everything is 100% scripted. And they are able to, since they are then sitting on the cloud with a hyperscaler like Oracle, they could rebuild everything in our London data center, or if you are on any other cloud vendors, in their London data centers, as an example, to rehearse. Because that is also a really important thing. You need to rehearse. You need to have a fire drill. I've been in my career in Oracle, I've kind of been Fireman Sam once in a while. Something goes wrong, then I have to go out. And what I'm seeing in most cases when there are a crisis, either because of something goes wrong, technology goes wrong, not just because of bad actors, there's a level of stress in the organization. So people do things wrong. And if they also need to start to figure out where do I have the documentation about the IP addresses, how I should reconfigure my Oracle database data guard in order to make sure that all the clients is able to log on to the database, where all the configuration files I need to change. And you do that in a stressed world after working for 24 hours, the likelihood of doing something wrong is very big. I was shutting down the Telia network in Norway because I was doing shutdown abort on a wrong database. A typical situation like that. But that was a day that the network is going up and down all day, so nobody really noticed that I was killing the wrong database and was shutting off the complete mobile network in Norway. But it happens, and it shows how important it is to have you need to have a response team, you need to have clear documentation, who is doing what, and you need to rehearse. And by moving most of the stuff to any cloud data centers, you can spin up a complete copy, play with it, rehearse, and when it's done, kill it. And that's kind of the beauty with the hyperscalers, that is much more difficult to do on-prem. So that's kind of summary a little bit what to talk about. Security of the cloud, that is the cloud vendor's responsibility. And I mean, trust all of us, we are doing a good job. Security in the cloud, that is all the tooling you have at your hand to make sure that you do the right thing. But most important was we discussed, and I think that is really where you should put the effort, is what I here call security by default, by design default, is move into the platform engineering way of thinking, the DevOps way of thinking. Make sure that you script everything. Use Ansible, Terraforms, whatever tool you prefer. Make sure that you don't do manual configuration on your infrastructure. It's under a normal software development lifecycle way of thinking. And finally, make sure that you secure your data in a proper way and you rehearse and test and do the proper fire drill. So that's mostly what I plan to discuss. Here are some links if you'd like to dig something more into it. It's from how we see it from the Oracle side. And that's... Any questions? I've been so silent, but I was warned. You are more silent than Finns, I was told.